we go.
So this is a bit of, there we go. So now that we're recording, let me try that again. So this is a bit of two purposes. So I know there was some interest in. I recently left Orca Security and joined an early stage startup called Minimus, and there was some interest in that. I also wanted to talk more about not just what we're doing, but where vulnerability management is with container images today, and sort of give you dive into what a container image is, how we sort of manage vulnerabilities in them, how all of that comes together, and what some of the meaningful ways of approaching it are. So this is I would have liked to have prepared more for this, but it's been an interesting week for reasons outside of this. So I'm going to dive into it and really sort of walk through some pieces of this. Now, starting with sort of the journey. We talk a lot about career in cloud security office hours. And one of the things I think you've heard everybody here say is your relationships are going to be part of your career. You are going to work with the same people over and over again. You're going to cultivate relationships. You're going to find yourself supporting people. You're going to find yourself competing against people that you know and love. It's becomes a very weird and incestuous place to be. In this case, after 2.5 years at Orca, I got presented with an opportunity to go work with the co-founders of Twistlock, which was the first startup I ever worked with. People who've been friends of mine since day one there, and in some cases before day one there. And there were several things about this that are particularly interesting to me. First of all, was that it's in the vulnerability management space, which is an area that I have had a really weird relationship with for about 15, almost 20 years now. In the sense that when I was at Microsoft, my team owned the security bulletin process. I got to deal with all of the vulnerabilities. I got to deal with lots of edge cases. I got to deal with and really disliked all of that, right? It was not part of what I wanted to do. And then at Twistlock, one of the things that Twistlock did was vulnerability assessment and management. Got very involved in where that went wrong and how we compared. So as part of proofs of concept, customers would say, "Well, you found 50 vulnerabilities here, and Aqua found 70. What's up with that?" And have to spend your time going, well, all right, that difference is 16 of those are false positives that we're rightly not detecting, and here's why. 4 of those are false negatives that we aren't detecting that we should be, and we're going to go fix that and working through all of that. And that's been a constant sort of everywhere that I've worked since then over the last 7 years or however long it's been. And then in the last year and a half, this has become a really critical set of problems based on all sorts of things happening. And so it's an area in which I think it may be the most critical problem facing facing us. I'm sorry, my laptop just decided to. Well, all right, I might have to. Sorry, I'm away from home. Apparently, I'm running low on battery. I'm just going to turn down my display here. But anyway, it's an area where I think it's incredibly important that we solve it in meaningful ways. And then the other thing for me personally is when I started at Twistlock, that was my first time in any sort of go-to-market, any sort of sales position. And the entire 2 years, Patrick Maddox was my boss, who is one of the contributors here, although I know he's not on this morning. He and I had a conversation every week about how do we build for the future? We had 6 technical pre-sales people. What do we do to prepare for when we have 60, when we have 600? And for me, I knew the technology. I really knew nothing about sales and go to market, and so I was in those conversations thinking about it, but really very raw. Now it's like an epic ring cycle, the conclusion of it, where I've gone through sales at several companies. I spent 2.5 years working in the marketing org. I actually know something about this topic, and I'm back working with and for Patrick, having exactly the same conversations about a new platform, a new product. How do we how do we build this? How do we prepare for what comes next? How do we talk about it? How do we demo it? How do we work through all of that? So for me, it's just really sort of compelling opportunity to do all of the same things again, but from a completely different position. So all of that was prelude. That was what I'm doing and why I'm where I am. But what I really wanted to talk about today is container images, what goes into them and how they put them together. Um, so I know this is going to be um, basic for some folks on the phone, and it's going to be incredibly advanced for others. As always, if something's unclear, if I use acronyms and don't define them, you want to dive in somewhere, you think I'm wrong about something, please speak up, ask questions, push on things. But I'm going to start with sort of how container images are built. And if I can click on the right things, I'm going to share my desktop. We're going to go full. I try to never share my desktop on a call, but we're going to do some things here and do it. So I've got a sample project. Now, in containers, the image is sort of the unit of everything. An image is what you're going to run, whether that's in Kubernetes in a deployment, it's in Docker on your desktop, it's in a serverless container. Yeah, thanks, Jay. I have a power supply. I just have nowhere to plug it in right now. I think, which is actually, you know what? I do. I'm gonna assuage Jay while I continue talking and while I dig through my bag to find my power supply. Um, so anything you run as a container starts as an image, and the idea is the image is a gold image. If I'm scaling up and I'm running 50 or 100 or 500 copies of it, every one of them is an exact copy of the image that I built to run it. And so this is one of the well, okay. Sorry, I plugged in here and I'm getting no power on. Oh, well, that's interesting. All right. Maybe there is no power here, even though there's a power. Oh, all right. Sorry. Anyway, I'm gonna just go fast. So every container is built to be, or every image is built to be this gold image that you're going to spin everything up off of. This is one of the founding ideas of containers, is that I can build this thing and it's going to run effectively the same whether I run it on my desktop, I run it in a Kubernetes cluster in AWS, I run it in data centers across the world, sort of wherever I run it. That's what makes it powerful. Now, the way I do this, there's effectively a language that builds a Docker file. And so if I look at the Docker file I've got here, this is a pretty simple Django image, which is a Python web server, effectively. Um, and so what this says is I'm starting with the Python image from Docker Hub, which is sort of the Python image most people start with. And what that is, that's an image that's already got all of the Python libraries, sort of everything that I need to run a Python application here. So I'm saying I'm starting with another image. I'm going to use that image. I'm going to expose port 8000 in here. I'm going to work from the directory my app. I'm going to copy my requirements.txt from my project into this folder where I'm working. Now, if you're not familiar with Python, requirements.txt is just a list of all Python modules I need to run my thing. In this case, it's basically Django, which is the framework I'm using. I'm going to run pip to install those requirements. I'm going to copy my source, all of my Python files into this. I'm going to say when this starts, we run Python 3 and we pass it manage.py, which is the Django, what starts Django. It's going to run our server. We're going to listen on all network interfaces on 8000. So not a really complex image. You'll see images that are much more complex. But this defines that I'm going to take the base Python image. I'm going to install what I need, copy my source files in here, run it, expose it to the network. Now, what's important about this is Docker images are built in layers, and each layer is part of a file system. And this is additive. And so I'm going to explain this. If it doesn't make sense, we're going to look at it in a minute and reinforce this. But every one of these commands creates a layer in my image, and that layer is going to have files in it. Now, each layer may add files, it may remove files, it may modify files. Typically, you're going to add files. So when I copy my requirements.txt in, it's going to add that file in a layer. You may sometimes remove files, like if you do apt get update, apt get upgrade to update files or update OS files inside of your image. You may clean that up in another layer, which will clean up sort of all the extra files related to apt upgrade, which will delete files in that layer. But that's what's important here. Each of these is a layer. We can add files, we can remove files, we can modify files. At the end of it, when we end up with a full image, when it gets loaded, it basically gets flattened into the file system that the container runs through. So let me stop for a second. Does that make sense? Any questions about that? If not, what we're going to do is give Docker a command to build this. Now, there are lots of ways to build images. This is the simplest one. What I'm telling it to do is I'm telling Docker to build this. I'm tagging it as Django, so I know, so it's easy to get to the image in a minute. And we're going to build it from the directory we're in. And so we're going to see Docker go through all of those layers. I've already built it, so it's very quick, but we can see it did all of those things, right? It pulled the Python image, it set my work directory at Carpenter requirements.txt, it ran pip install, and I ended up with an image. And so I can look and I can see I've got that local image. It's 1.5 gigs. Now, we want to talk about vulnerability management. A couple of things about vulnerability management with containers that makes it a little unique. Typically, and if you've ever heard me do a presentation about vulnerabilities before, you've probably heard me say this, but managing vulnerabilities in containers is the same as managing them everywhere else in one sense. If I have a vulnerability that allows for remote code execution over the network, and it's running on a bunch of VMs in my data center, or it's running on a bunch of containers on Kubernetes on Google Cloud, the impact of that is effectively the same. Somebody can exploit it, maintain persistence, do recon, move laterally, all the things that they're interested in doing. What's different is how I fix it. So if I've got it running on a bunch of VMs in the data center, I create a ServiceNow ticket, somebody comes along at 3 a.m., patches them, reboots them if they need to, closes the ticket, I patch that vulnerability. A bunch of containers though, because each of them is a copy of this gold image, I can't, or more specifically, I shouldn't patch them all. I technically could. It would be a very bad idea because anytime one of them restarts, it's going to start again from a copy of that image. It's going to start with from a vulnerable place. You don't patch running containers. What I have to do is get back to the developer who built it, like we just did, get them to patch, update, fix the vulnerabilities, rebuild the container, retest it, reship it, redeploy it everywhere it's currently running. So even though I've got the same set of problems, the same risk, effectively, I've got a completely different set of constituents and a completely different process for fixing. So it becomes more complicated. Now, there are reasons it's better as well, but it is more complicated for me to get this fixed. And I can see, I'm going to use Trivy. There are lots of ways to scan containers for vulnerabilities. So I'm going to tell it to scan the Django container that I just created locally. And what I'm going to find, if I remember right, this is going to scroll way off the screen, but I've got about 1,500 vulnerabilities in here. And you can see some of them. So I can see the version of Django I'm using. There are 3 vulnerabilities. I'm using 5.1.6. I really need 5.2.1. But otherwise, there are a ton of other vulnerabilities in here. Now, these vulnerabilities, some of them I probably don't care about. Matter of fact, a lot of them I don't care about. They're low and medium severity. They're not fixed. They won't be fixed. But this is still 1,500 vulnerabilities that I've got to work through, triage, deal with, manage. And some of them, like I love this one right here, zlib. It's an almost 2-year-old vulnerability. It's critical severity, but it's will not fix. That tells me if I go look into that, it's probably not a very interesting vulnerability. It's technically a critical CVE, but nobody cares. And so this is a ton of work to manage these vulnerabilities. And what we know happens, there's a great piece of research I keep citing that says that organizations manage to patch about 10% of new vulnerabilities they get every month, um, which is not, I think, a rule of nature for reasons we'll talk about, but it is definitely something you can see if you work in vulnerability management. There are tons of vulnerabilities that never get touched, but you're investing effort in them. You're spending time triaging them, sorting in, sorting out, trying to work with developers to get there, right? And so you're spending all this time on it. By the way, Haji asked if I recommend any free scanning tools. Um, to a certain extent, the scanning tools are fairly commodity. You've got Trivy, you've got Claire, you've got Gripe. There are a couple of others I'm not thinking of. I've been having some weird experiences with Gripe recently, but for the most part, they return the same vulnerabilities. It's much more a matter of which one matches your workflow better. Ultimately, I think as you move forward, you will end up on paid tools because of the amount of work that's in here, right? You're going to move from personal projects and small teams using free tools to paid tools over time. But I think any of the free tools are roughly comparable. I like Trivia. It gives good output. It's got good options. Um, so this is all the vulnerabilities. Now I mentioned that we're dealing in layers, and this is built in layers. Um, Depending on how I got this output, I can actually take and map all of these vulnerabilities to which layer they're in. I'm not going to do that here, but I'm going to use another tool called Dive. And Dive is kind of a fun tool. What Dive lets us do is actually look at all of the layers in here and what happened in this. So if you happen to remember our initial image, this view may confuse you. On the upper left here where I'm going, these are all of the layers in the image. And you remember our first line was from Python. Our second line was workdir/myapp. So why are there like 6 layers here before I get to the second line in our Docker file? That's because when I say from Python, what I'm really doing is pulling all the layers in the Python image into my image and building on top of them. So all of these layers are coming from Python. This initial one is whatever, I think it's Debian it's based on. And then if I went and looked at the Docker file that builds Python, it's doing all of these things. And I can see what it's doing. It's going and getting the latest version of python.tar.xz and extracting it and et cetera, et cetera. And so now if I go over here on the right-hand side, it shows me the contents of each layer. And down at the bottom, there's a set of filters. I can look at only what's added, removed, modified, unmodified. I'm going to turn off unmodified. And then what I can see is in each layer, here's just what was added in this layer. Here's what was added in this layer. So I can see, for example, when we copy in our requirements.txt, there's my requirements.txt. It's the only thing that was added in this layer. When I do my pip install, I can see all of the things that were added when pip install did what it does. And I can see here's where all the Python in that I copied in gets copied in. So I'm gonna pause for a quick second. Oh, good. Claire has a major bug. They're all commodity, but they all sort of have their own sets of problems as well. So does this make sense how this is built in layers and why I would have vulnerabilities in different layers for different pieces coming out? And if it doesn't, somebody please speak up and ask a question, but I'm going to say, as an example, here is where I run my pip install for my requirements. This is where Django and all of its different pieces get installed. This will be meaningful to us in a minute. We already saw it, but we'll come back to this. Thank you. Yeah, Dive is a really cool tool that I play around with a lot recently because I've been spending a lot of time diving into container images and what's in them. Now, from here, sort of the interesting thing is, how do I manage if I say people can only patch about 10%, how do I manage that? Right? If I can only patch 10% and I try to patch everything that's high and critical, which is way more than 10% of all vulnerabilities, I'm not going to I'm going to end up patching a lot of stuff that's really not very valuable, but happens to be critical. Obviously, I won't patch this one because it's critical will not fix, but there are going to be other critical ones that do have fixes available. And I apologize. I'm surfing. I've got 10% of battery, so I'm going to try to wrap this. But so how do I manage that? How do I manage that 10%? From my mind, there's really three approaches that are interesting here. The first one is it's what Wiz and Orca and everybody else in that field is doing, as well as a lot of the AppSec players like Sneak and Aikido and sort of everybody. And it's how do I target the right 10%? So I move beyond just what is the criticality of the vulnerability? Is it critical? Is it high? Is it medium? Is it low? And look at things like, do we know that it's being exploited in the world? So what's known called KEV, known exploit. I think the V is vulnerabilities, but now that I say it out loud, don't quote me on that. There's CSOH, which is the U.S. government's official list of what's known to be exploited. There's other known exploit intelligence, but if something's known to be exploited, that tells us that it's probably riskier to not patch it, probably significantly riskier to patch it. There's also how likely is it to be exploited. So last year we had Stephen Schaefer, who was at Peloton at the time. He's moved, I forget where now, come and talk about EPSS, which is a measure of how likely is something to be exploited. There's a lot of thinking in that space as well. But if something's 92% likely to be exploited, it's a lot more interesting than if it's 0.1% likely to be exploited. And it turns out about 10% of vulnerabilities are probably more than 2% likely to be exploited. So about 90% of them are less than 2% likely to be exploited this month. There's other stuff that's going to fit in here, like asset context. If something's vulnerable on an asset that manages a critical process for my company, it's a lot more interesting than if it's vulnerable and it's on something that's not exposed to the outside world, doesn't do anything interesting, and doesn't have connectivity to anything interesting. Also, reachability is a big new space here. Reachability is the idea of not just can I access it? Can I get to the VM or the container or whatever it is where this is running? But can I get from the edge of that? Can I get from something that's listening on it to the actual code that's vulnerable? And before I left Orca just announced two significant reachability functions in the platform. Before I left, that stuff was in beta and we were spending a lot of time with it. And it turns out in a lot of the cases we looked at, the containers that we were looking at, only about 10% of the stuff in there that was vulnerable was actually reachable at all from the entry point in the container. In other words, 90% of the stuff in the containers that was vulnerable could never actually be used as best we could tell by that container. So that's an important signal to say, here's what I need to focus on, here's what I don't. Now, that still sits within that 10%. I can only fix 10%, so let me focus on the right 10%. The second approach, I mentioned Stephen Schaefer earlier. Stephen, in the last few months, has been talking about something he calls EPSSG. And the idea is, generally speaking, if I'm going to fix one thing because it's critical, it's got a high APSS score, whatever else, are there other things I can fix at the same time with minimal impact. So if I'm going to patch this one thing, I can patch these 5 other things that are related. It doesn't cost me more to test. It doesn't cost me more to rebuild. It lets me patch more. This is one way I think we're going to get outside of that 10%. This is also an area I think there's a lot of early research going on. There's not been a ton of sort of guidance and productization of that yet. I sort of expect it'll come. It's going to be an interesting way to break outside of that. Now, the third approach, and this is the last bit of what I'm going to talk about today, is minimize the amount of stuff I'm putting into it to begin with. And I'm going to go back to something I just said. At Orca, when we were looking at reachability, only about 10% of the vulnerable stuff we saw in containers was actually reachable. In other words, 90% of the stuff in containers sort of don't take that as a statistically accurate survey, right? But roughly speaking, anecdotally, 90% of the stuff in many containers is unusable. It just happens to be there. So you're scanning it, you're generating JIRA tickets, you're going through all of this work for something that actually is never usable. And I think even if you invest in reachability, you've still got a lot of that, right? You're still generating all of this noise. So the thinking behind Minimus and Chain Guard and a couple of other things going on out there is, what if we put less garbage in? What if we just put in what we need? Then we can actually reduce the amount of vulnerabilities we ever have to look at. We can enable our teams to focus on only what they own, what's important to them, and we can go from there. So that's what Minimus is a collection of minimal container images, both things that people need directly, like Nginx, which is used by a ton of different projects. It's just a front end, and things that they're building on, like our Django image here. And I see some things.
Good morning.
Okay. Sorry, what was that? Okay, so let me show you the last mile of this, right? And obviously, I'm going to show you with the Minimus image because that's what I have. But the idea is, I've got 1,500 vulnerabilities in this image. It turns out only 3 of them are coming from what I added to it. 1,497 of them are coming from my base image. So what if I ripped out everything I didn't need and went and did a better job of this? And so I built this same image, but on top of Minimus's Python 3 image. Now I had to refactor this a little bit. My Docker file is not as simple. This is a better build, but I did have to do a little bit of work. Now what I'm doing here, there are 2 things. First of all, the Minimus production images and many of the minimal images you're going to find don't have a shell in it. That's attack surface. I don't need a shell for something that's running in production typically. It doesn't have wget. It doesn't have a ton of tools in it. So I cannot build my image using the production Minimus image like I do with production Python image, which has a shell. As a matter of fact, it has multiple shells and it's got all the tools, it's got everything. So I have to we create dev images, which have the shell, which have tools I need to troubleshoot. So you'll see I'm starting by using the dev image instead of the production image, pulling it from reg.mini.dev. By the way, you can go to minimus.io, you can register, you can test all of our images for free. You can only use the latest image. Your pull key will only be good for 30 days, but you're welcome to play with these and work with them. The other thing, because we've also hardened the images, we don't run as root by default. There's some other work that we do. I have to create a Python virtual environment so that I can manage everything as a user. So what I'm doing here is creating a virtual environment. And otherwise, you're going to see similar stuff going on. I'm setting my work directory, copying creating my virtual environment, copying my requirements in, installing everything, copying my source in. And then this is what's called a multi-stage build. I define the first piece as builder, and then I build my actual image. So I copy everything from the builder image into this image. I chown it. That is, I set the user to the user that we're going to use and not root, because it was root in the first to begin with. I set the entry point and I run it. And so now I end up with functionally the same image. It's going to run my Django app. It's going to serve it up. And if I So I'm once again building it. I'm calling this one Django Mini. I'm feeding it. I've got a different Docker file, so I have to specify that. And we'll see it go through and build it. Once again, pretty quick because all the layers existed locally. So now, first of all, I go from having a gig and a half image to 167 megabyte image. Scraped all of that stuff out, right? Everything we don't need is now gone. I've got a very minimal image. Now, first, not first of all, I'm way deeper than that, but if we scan this again, I'm going to like what I see. I now have 3 vulnerabilities all in Django that I added on top of it. Now, I am going to say this is not the primary benefit. This is a side effect. The primary benefit is not that I have 0 vulnerabilities or 3 vulnerabilities in its management a day. The benefit is really that this is going to be more resilient. It's going to reduce my workload through that entire life cycle. Because there are 3 vulnerabilities in this today, but we know new vulnerabilities are going to be found. In fact, last week there were 2 vulnerabilities in this image. There is 1 brand new one in it today. So if I go fix these and then deploy my image today, I'm going to find new vulnerabilities over time. But what's going to happen is that original Python image, that fat Python image, if you want, I'm going to get lots more new vulnerabilities over time that I have to manage throughout the entire workflow. Here, we've significantly reduced that, and we're reducing pressure on the entire vulnerability management workflow by doing it, as well as hardening it by default. So we're in a much better place. And if I, once again, dive into this, I can see what I've got here is much more manageable. Now I've got only that, which is, I've got 2 layers because the bottom layer is that Python image from Minimus. And then just when I copied into it, I've got only those files. I've got a very efficient image there. So let me, hopefully that gives you a bit of an understanding of how container images work, what we're doing for vulnerability management. And any questions, comments, thoughts on this before my battery actually does run out here?
I've got one quick question.
Yeah.
So when we're going from a container, like we're going from the dev image to do our stuff to production image, and then I noticed that was all in the same Docker file. Is that doing like a lot of when we go to the production image, is that doing like a lot of like removing of packages basically? And so it's like diffing between the two and going, okay, well, I don't need these now, strip all that out.
So actually multi-stage Docker builds are an interesting thing because yes. So ultimately what happens is what ends up in my actual image is only from the last from statement down. And I don't know why I'm pointing at my screen like you can see that. But so I can do lots of things in multi-stage Docker builds. If I'm building a Golang project, for example, I may compile my Golang app in one stage and then just copy the Golang binary into the final image down here.
Okay.
So I can do anything I want. I can compile stuff. I can build stuff. I could just print hello world 100 times. Ultimately, the last from statement is the only one that builds the image that actually gets output.
Okay.
And so what I'm doing here is I'm using this first stage to just build everything I need. So it's building my Python virtual environment with Django and all of its requirements in it. It's copying my source code in there. And then down here in this copy line, it's saying, take the file system of the builder image, copy the my app folder there, which includes my virtual environment, because that's where as well as all my source code, and copy that into the my app folder on this image. And set the owner to user ID 1000.
Okay, that makes complete sense. Thank you.
So it's a really good strategy overall for building images because you can do sort of compiling and building and doing everything you need, get that out of the way, and then take only the things from those intermediate images and pull what you need into your final image. So I really wouldn't, the first Docker file I showed is the example you'll see in like every tutorial about building a Python image for Docker. it's not how I would build a real production image. I would do something like this typically. But it's much easier to talk about the other one. Yeah, Golang is super nice for doing this. I would agree. I'm a huge fan. But there's a separate set of vulnerability management problems there where Golang vulnerability management is just stupid. But I probably don't have enough battery to go into why that is. So any other questions, comments, anything else?
So when's the drawing for the Mini Cooper, and who here is going to get it?
It is by tomorrow. I am not part of the selection committee, so I cannot comment on that.
They won't
Rubbish.
ship it to Singapore though.
I imagine there'll be like $150,000 price
Well-
tag with that. It'd be wasted on me.
Well, you had to show up in our booth to be fully registered. So
There's always a catch, man. There's always a catch.
there is a catch. And by the way, fun story. It is not a giveaway. It is a skills-based contest. You had to, when you registered, you had to tell us what we should give away at Black Hat, which is the skill, which the decision is made on. If it was a giveaway, it's a lottery, it's gambling, and it was incredibly complex. If it's a
Gotcha.
skills-based giveaway, the state of California was fine with it.
Makes sense. Love
God.
it.
I saw Jay's got his hand raised.
Yeah, just two quick questions. I saw somewhere that Minimus had some link to Gutsy, but maybe it's like Phoenix from the Flames kind of deal. I'm not quite sure. Was hard to find info on it. And maybe the second one that might be even quicker is Chain Guard, so if your main competitor. Would that be right?
So yeah, the second one first. I would say in terms of companies, Chain Guard would be the main competitor. I suspect, having spent some time at RSA talking to people, it was kind of rough being in complete stealth. Like nobody outside of our employees and investors knew what we were doing until last Monday. So that was the first chance I had to really talk to people about what we were doing in the market. And it turns out, I think our real main competitor is everybody who's just building their own images right now. Like Chain Guard's been around for a while. I think they're doing great work. I have a ton of respect for them. But even then, they're not really well known outside of the people sort of deep in this space. I had far more questions about anything other than Chain Guard last week at RSA. So, I think, they're the company we're competing against, but ultimately this is a wide open field right now. There's lots of room for people. The first question, yes. So Minimus is Gutsy, the company rising from the ashes, and reorganized and rebranding.
Yeah, Shesh, I see your hand up.
Yeah. Thanks, Neil. This is great. So my question is more from, value prop perspective. And I would love to know, industry leaders' thoughts about, so we are now using much more tighter base image that's boiled down to, very small number of CVs, percentage-wise or number-wise. What happens when, the developers at a larger organization, they're provided these images, but they have free reign to download any and all packages for their work, right? They have, how is that controlled? Because again, you are going to have one vulnerability spawn there. And what's the overall value prop, even when we are using, tighter base images? Because we may have 10 million images, but if the number is just going down to be 50% less, which is 5 million vulnerabilities, like what's the value prop? I'm just trying to understand the industry from that standpoint.
And I will jump in first.
Bye, Neil.
Yeah.
The time. Who's got what?
That was it.
Guess I'll stop the recording.
His phone die or something?